FMTH-Trigonometry. And today we are going to discuss about compound angles. Suppose we have this relation up here. Now for the following, what will be the answer? Is this your thought? Sin A plus B is this, cos A plus B is this, tan A plus B is this. If this is your thought, then you are wrong. So what is the correct answer? Consider this rectangle. We all know for a rectangle, opposite sides are equal. This side equals this side, likewise this and this. And all the interior angles are 90 degrees. So from here, let's try to draw a line here, such a way that when we join the point to this, we are going to have another 90 degree over there. Something like this. This angle here is 90. Then let's join this point. Let's show all the right angles. The whole of this 90 degrees. So now, let's label this angle as A. And this angle here as B. So the whole of this angle here is 90. So if everything here is 90, this one alone will be from 90, we'll remove A and B. So there is going to be 90 minus A plus B. And by doing so, this is 90 degrees. Look at this rectangle triangle. If this is 90, for a whole triangle that is 180, then this and this must be 90. So if we remove the whole of this from 90, we'll get this. So this angle here is 90 degrees minus the whole of this, which will give us A plus B. You can do it out. Let's try to label all the angles. So if this angle is A and this is 90, what's left here has to be what? 90 minus A. Which other angle is left? This one here. If this angle is B and this is 90, what is left must be what? 90 minus B. So what is left? This angle and this angle is left. For this, total angle in a straight line is 180. So if I remove A plus B, 90 minus A, from 180, we are going to get the angle here, which is going to be, this angle will be 90 minus B. This one is 90 minus B. Then all be here. So since this one is 90, so if we remove 90 minus B from 90, we get this, which is going to be B. So using sum of angle in a triangle. So we've labeled all the angles. Now the side. So let's start with this triangle at the center. Let's call this one 1. Let's call this 1. So it means the hypotenuse is 1. So let's try to get the value of this. So if you are considering angle A, this is opposite. So what is opposite? Let's call it X. So from here, this opposite, this is what? Hypotenuse. So that's sine A is what? Opposite hypotenuse. From here, what is X? X is sine A. So it means this side is what? Sine A. So let's replace X with sine A. Let's move on. Now let's get this. This is the adjacent. So this is opposite, this is the adjacent. Let's call the adjacent Y. So if I do cos A, it is the opposite, which is sine A. Sorry, adjacent, which is Y, to the opposite, which is 1. So cos is adjacent over hypotenuse. That's Y over 1 from here. Y equals to cos A. So we can replace this Y with what? With cos A. Cos A. Let's come to this triangle here. If this is 3, this is the opposite. So let's call this one X this time around. So opposite hypotenuse, what is 90? So meaning if I do sine B, I'll have opposite over hypotenuse, which is cos A. From here, it means X is sine B cos A. So I can replace this X with what? Sine B cos A. So this side is known. Next, let's get this side. Let's call this side Y. So if I use cos B, that's the adjacent over hypotenuse. Adjacent is Y, hypotenuse is what? Is cos A. From here, it means Y equals to cos A cos B. So we can replace this Y with what? With cos A cos B. So we are done with that triangle. Now let's consider this small triangle here. For this small triangle here, this angle B, this is opposite to it. Let's call it X. So this is the opposite, this is the hypotenuse. So if you do sine B here, so sine B equals to the opposite, which is X, hypotenuse A, which is sine A. So in this case, X becomes sine A, sine B. So we can replace X with what? With sine A, sine B. Now let's get this side, let's call it y. Let's get y next. So to get y this time around, we are going to use cosine. We use cos b. So this is the opposite, that's adjacent hypotenuse. Adjacent hypotenuse. From here, y becomes what? Sine A cos b. So we can replace this y with what? With sine A cos b. So we are done with this triangle, this triangle, this triangle. We are left with this what? Triangle, the last one. Now for this last one, let's call this side x. So with this angle, this opposite hypotenuse, that's sine. So it means sine A plus b is the opposite x over hypotenuse, which is 1. From here, what is x? X is sine A plus b. So this side actually represents what? Sine A plus b. And lastly, let's get this side from here to here. Let's call it y. So using this angle, this is opposite. So y is adjacent. Adjacent hypotenuse is cos. So if you do cos A plus b, cos adjacent hypotenuse. So from here, y equals to cos A plus b. So you can replace this y with what? Cos A plus b. We are done, or let me say we are almost done. Now, since this is a rectangle, the whole of this side must be equal to the whole of this side. So what do you have here? So here, all the side is sine A plus b. And that equals to the whole of this side. And what do you have here? We have, from here to here is sine A cos b. From here to here is what? Sine B cos A. So we are going to have sine A cos b plus sine B cos A. And that is the answer. So it means this one is wrong. This one is not. It's the correct version. Now, what about cos A plus b? Cos A plus b. So this is where cos A plus b is. From here to here is cos A plus b. From here to here is what? Cos A cos b. So if you remove this one, this portion, if you take it out from the whole of this portion, we will be left with this one. So it means cos A plus b is what? The whole of this line minus this. And the whole of this line is what? Cos A cos b. Then minus, what do you have here? Sine A sine b. That is for what? For cos A plus b. So this is wrong. This is the correct one. What about tan A plus b? Anytime you have sin and cos, you can always get tan. What are we going to do here? We divide this by this. And after that, we can rationalize by multiplying numerator and denominator by cos A cos b plus sin A sin b. And from there, we are going to have something beautiful. At the end of the day, after simplification, we are going to have this to be tan A plus tan b divided by 1 minus tan A tan b. So this is wrong. This is the correct one. But this is not the end, because you can see ask to look for sin A minus b, cos A minus b, and tan A minus b. What will be the answer to each case? Note, if I have sin A minus b, instead of writing sin A plus minus b. What does it mean? It means we replace this b with what? Minus b. Finish. So I'll come and write sin A, then cos minus b. But the good news is cos minus b is same thing as cos b. We've done that earlier. Cos minus b is same as cos b. So we just write this as well, cos b. Then plus sin minus b cos A. But the thing is, sin minus b equals to minus sin what? Minus sin b. So what happens? This minus, you can bring it out and it will affect this one. This becomes minus. So I'll be having what? Sin b cos A. So over this one, note, anytime we replace b with minus b, cos remains. So this is still what? Cos A cos b. It is sign that changes. So if I replace this sin b with sin minus b, the negative will come out and affect this one, and this will become plus. Plus sin A sin b. What next for tan? Same way, only cos remains if you have a negative angle. For tan, b will also what? Change. So if I replace this b with minus b, this turns to tan A minus tan b. Why? Tan negative b will be negative tan b. That be 1. Negative b here will come out and affect this become plus tan A tan B. Find a way to commit everything we have here to your memory. Note, for sign, if you have plus here, this is plus. If you have minus, you have minus here. For cos, plus here, minus here, plus here. Plus, minus, minus, plus. You just have to commit this to memory. So the good news is, I don't think I've come across any O-level question where you are told to prove this. You don't need to understand how these formulas are gotten, but you have to know this formula by heart. In fact, it is better you memorize than learn how to prove it. Why? Because in case you forget the formula, it is difficult to prove. So it takes us over about 10 minutes to prove this. So it's better you commit this to memory, because this we needed for what we call double angle, triple angle, even half angle, and the product rule under Earth trig, or the product formula. Now let's go to double angle. What is double angle? Suppose we want to get the value of sine 2a, cos 2a, and tan 2a. What will be their values? So we call this double angle when we have sum of two same angle. That's sine a plus a. We know that 2a, sine 2a, can be written as sine a plus a. And recall that sine a plus b, what we just did is what? Sine a cos b plus sine b cos a. So from here it means sine a plus a becomes sine a. So anywhere we see b, replace b with a. So this is what? Cos a plus another b replace with a. Sine a cos a. So from here you can say sine a plus a 2a equals to sine a cos a, sine a cos a. So that's 2 sine a cos a. That is the identity for sine 2a. Before we continue, recall the trig identities. Recall all these trig identities, especially this particular one. Very important. They are all important, but this one is most important. What about cos 2a? Cos 2a is written as cos a plus a. And recall, cos a plus b is cos a cos b minus sine a sine b. So it means cos a plus a. You replace, it means anywhere you see b, you replace b with a. So that's cos a, cos replace b with a, minus sine a, sine replace b with a. So from here it means cos 2a equals to cos square a minus sine square a. But we're not going to stop here. Why? Since the main thing we have here is cos, our answer should be in cos form. So I can leave it as what? Cos square a minus, what's that sine square a? From here, sine square a equals to 1 minus cos square a. 1 minus cos square a. From here it means cos 2a equals to cos square a minus 1 plus cos square a. From here it means cos 2a equals to cos square a plus cos square a, that's 2 cos square a minus 1. That's the main identity. Or we can express cos 2a in terms of sine. So what are we going to do? We replace this what? Cos square a with what? 1 minus sine square a. So this becomes 1 minus sine square a minus 1. That's 2 minus 2 sine square a minus 1. 2 minus 1 is 1. That's 1 minus 2 sine square a. So it means cos 2a can also be cos 2. Let me write this below. Cos 2a in terms of sine equals to 1 minus 2 sine square a. So please, cos 2a can be expressed in terms of cos or in terms of sine. This is very important. It's going to be needed. So the next one is tan 2a. What will be tan 2a? So tan 2a can also be written as tan a plus a Cos A plus A is 2A. What's that tan A plus B? Tan A plus B equals to tan A plus tan B divided by 1 minus tan A tan B. So this time around we replace what? To get the value of tan A plus A. It means replace this B with A here. So that will be tan A plus tan, what's that B? A. 1 minus tan A, tan B is also A. So from here we can say tan A plus A is 2A equals to tan A plus tan A is 2 tan A divided by 1 minus tan square A. Because tan A multiplied tan A is tan square A. So double angle for sine is this, for cos is either this or this, for tan is this. If you know double angle, you can go to triple angle, you can go to 4 angle and the likes. So let's just do triple angle, then we'll go to half angle. Before that, note everything inside the box, you must commit them to your memory. For triple angle, you don't have to memorize it. So if you know double angle, you can always derive triple angle yourself. So what is sine 3a? Sine 3a can be expressed as sine 2a plus a. Yes. And what is sine a plus b? Sine a plus b is sine a cos b plus sine b cos a. So it means sine 2a plus a becomes, anywhere we see a, we write 2a. Anywhere we see b, we write a here. So I have sine, now I'm having a here, I'll replace a with 2a. Then cos b, I'll replace b with a. Plus sine, what's b? B is not a. B is a is 2a. B is a, then a is 2a. Then we have sine 2a cos 2a. Double angle, double angle. Let's replace back. So from here, this is sine 2a plus a back to 3a equals to, what's that sine 2a? So sine 2a is what? 2 sine a cos a. This represents only sine 2a. Then we see how what there? We see how cos a plus sine a. What's cos 2a? Now since it's sine, the best is to express the answer in terms of what? Sine also. So cos 2a has two identity. We are going to use the one with sine. And we check what we did previously. Cos 2a is what? 1 minus 2 sine square a. So it's also equals to 2 cos square a minus 1, but in this case we are going to use sine. So from here it means sine 3a becomes 2 sine a. Cos a is what? Cos square a. Plus sine a times 1, that's sine a, minus 2 sine cube a. Sine a times sine square a is sine cube a. Next, we don't want to see cos. We recall cos square a is 1 minus sine square a. So from here, it means sine 3a becomes 2 sine a. What that cos square a? 1 minus sine square a plus sine a minus sine cube a. So when we check, we have sine a here, we have sine a here, we have sine a here. So if we factorize sine a, here we let it what? 2 into 1 minus sine square a plus 1 minus 2 sine square a. We factorize sine a from every side. This one becomes 2 alone. This one 1 here. So what next? We can say sine 3a equals sine a. Let's expand. 2 times 1, 2 minus what? 2 sine square a plus 1 minus 2 sine square a. From here it means sine 3a equals to sine a into bracket. 2 plus 1 is 3. Minus 2 is minus 4. Minus 4 sine square a. So you can pause there. That will be the answer. Okay, what about cos 3a? Cos 3a can be written as cos 2a plus a. And recall, cos a plus b equals to cos a cos b minus sine a sine b. So whenever you see 2a, we represent it with a. Whenever you see a, we slot in b. So from here it means cos A. So when I see A, write 2A. And then when I see B, write A equals to. If we see A, what are we going to do? We write what? Sorry, it's from here. If you see A, we write 2A. If you see B, we write A. So if I see A, I write 2A here. Cos, if I see B, I write A. Minus sine A is 2A. Then sine, what is B? B is A. So A plus 2A plus A is cos 3A equals to. Now what is the identity for cos 2A? If you check cos 2A, this time around in terms of cos 2A is what? 2 cos square A minus 1. That's cos 2A. Then we have times cos A minus what? What's sine 2A? Let's write sine 2A in terms of. Sorry, it's also the one form. Sine 2A is always what? 2 sine A cos A. So that's for sine 2A. Then we have what? Sine A again. So from here it means cos 3A becomes, let's see, cos A is here, cos A is here. So let's factorize cos A. So I'll be left with everything here. That's 2 cos square A minus 1. Then here we've taken out cos A. I'll be having 2 minus 2 sine A times sine A is what? Sine square A. So from here we are going to have 3 cos 3A equals to cos A. We have 2 cos square A minus 1 minus 2 into, what is sine square A? We want our answer to be in cos. So sine square A is 1 minus cos square A. 1 minus cos square A. Now let's continue. Now let's expand. Here we still have 2 cos square A minus 1 minus times 1 minus 2 minus minus plus 2 cos square A. 2 cos square A plus 2 cos square A, that's 4 cos square A. Minus 1 minus 2, that's minus 3. And that is the final answer. If you check, there's a pattern. For sine 3, there's sine outside. Then we have 3. Then sine square A, 4. Cos square A, 4. We have 3. Just that the 3 is positive, the sine is negative. Here, the cos is positive, the 3 is negative. What about tan? So same way, tan 3A is tan 2A plus A. So from there, tan 2A plus A, using the rule of tan, that will be tan 2A plus tan A over 1 minus tan 2A tan A. Then what happens? We replace tan 2A with its identity. And tan 2A is what? 2 tan A over 1 minus tan square A. So you can come and write tan 3A because 2A plus A is what? Then what's tan 2A? That is 2 tan A divided by 1 minus tan square A. Then here I still have plus tan A. Then divided by 1 minus, what's tan 2A? Again, 2 tan A over 1 minus tan square A. Then tan A. What next? This multiply this. This also multiply this. And at the end, these two will cancel each other. So we are going to have, this is what we are going to have. And from here, if we simplify further, we will have this. Then from there, we will have, at the numerator, this and this. 3 tan A minus tan cube A. At the denominator, we'll be having 1 minus tan square A minus 2 tan square A, that's minus 3 tan square A. So we can leave our answer like this. What next after 3? 4. So what's sine 4A? What is cos 4A? What is tan 4A? In case you are asked, what are you meant to do? Just replace sine 4A with sine 2A plus 2A. We already know sine 2A as cos 2A as the identity you impute, and that's it. Now let's move to half angle. Half angle. For example, We are told was sine half of a, or a over 2. How do you go about this? So you have to note that sine half of a plus half of a is certain as sine a. How? Half of a plus half of a will give us what? A. You can also write this as this. Recall that half a plus half a, here we have two halves. So you can still write this as what? I can say sine a equals to sine 2 multiplied by what? Half of a. So what is the identity for sine 2a? In this case, I'll call it sine 2 theta. Sine 2 theta is what? 2 sine theta cos theta. So in this case, our theta is what? Half of a. So it means sine 2 times, if this is 2, theta is what? Half a. Half a equals to, theta is always half a. 2 sine half a cos half a. From here it means sine a equals to 2 sine half a cos half a. Let's take it as it first. Let's pause it for now and let's go for cos. Same way, you can say cos a equals to cos 2 into what? Half of a. So and what's cos 2 theta? Cos theta from the identity earlier is 2 cos square theta minus 1. So it means cos 2 half of a. This time our theta is now what? Half of a. That's 2 cos square half of a minus 1. So this is what? Cos 2 times half is 2. That's cos, sorry, cos to 1 rather. So that's cos a equals to 2 cos square half of a minus 1. Note, our aim is to know the value of what? Cos half of a. Because our aim is half angle. So if you make this one the subject, I can bring this one here. So that will be cos a plus 1 divided by 2 equals to cos square half of a. So to get this one, we'll find the square root of both sides. So the square root of this equals to this. So this takes away. So it means cos half a equals to square root of cos a plus 1 over 2. It is easier for you to get the value of sine half of a from here. Why? We know that sine a or sine square a, let's say sine square theta equals to 1 minus cos square theta. So it means sine half of a equals to 1 minus cos square half of a. So sine half of a equals to 1 minus, what's cos square half of a? From here, it's as though we are squaring this. If you square this, you'll be having what? Cos a plus 1 over 2. If you square this, the square root of this one will be, so we let it cancel. So from here we can say sine half of a equals to 2 times 1, 2. That's 2 minus cos a plus 1 over 2. So from here it means sine half of a becomes 2 minus cos a minus 1 over 2. So sine half of a becomes 2 minus 1 is 1. 1 minus cos a over 2. So this is formula for half angle for sine in terms of cos. So it is easier for us to express it in terms of cos. Sorry, they should be square. Yeah, they should be square from here. There is square here, there is square here, there is square here. So there is square here. So there is a square. To remove the square, we look for the square root on both sides. So we are having something like this. So very beautiful. 1 minus cos a over 2. This one is cos a plus 1 is certain as what? 1 plus cos a. So that it will look the same. 1 plus cos a. What difference for cos addition, for sine subtraction? So what will be for tan? We know that tan is sine over cos. So definitely if you do tan half of A, it equals to sine will be up. That will be this divided by this. That will be 1 minus cos A over 2 divided by what? What do you have there? Cos 1 plus cos A over 2. In mathematics, if I turn this on to multiplication, the 2 goes up, 1 plus cos A comes down. This cancels this. So from here, it means tan half of A equals to square root of what? Square root of 1 minus cos A over 1 plus cos A. And that is it. Now the question is, why is this half angle useful? You know, we have special angle like 30. So we know that sine 30, or let's say cos 30, let me use another marker. Cos 30 degree is a special angle, and the answer is root 3 over 2. So the question is, what's that cos 15? So 15 is half of 30, right? So in that case, you now come here. It means cos half of what? What 15 half of 30 equals to square root of 1 plus cos, what's A now? The whole of this, 30 over 2. So it means cos half of 30 is 15. Cos 15 equals to square root of 1 plus, what is this? Root 3 over 2 divided by 2. So the final answer equals to square root of 2 plus root 3 over 4. And that's square root of 2 plus root 3 over 2. And that's the answer. What if you are not told to look for cos 7.5? 7.5 is half of 15. So repeat the same step. Since we know the answer of the value for this already. So that is the usefulness. So we can get what? The half of any angle we already know. So for example, we know cos 45. Right? So what will be, let's say, sine half of 45. What value of sine 22.5? If you are told for this one, this is half of 45. So in that case, we are going to use this formula. So if you are given sine 45, before you can look for half of it, we have to first get cos what? 45. And you can always get that using 1 minus cos square theta. So to get angle like half of special angles, like half of 45, 20.5, half of 30 like 15, half of special angles in general, we can always use what? Half angle for that. Okay, you can note everything here before we move on. The next is for us to talk about product to sum formulas. Product formulas. If we have sine A, sine B, the product of two different angles of the same trig ratio, what will be the answer? Same goes for cos A, cos B. Then we can also swap. We can also do sine A, cos B. We can also do sine B, cos A. For each case, what will be their formula? We can get this one using the compound angles. I'll write down the formulas, then we'll show the proof. For the first one, then for the next. Then the next, sine A cos B. Then last one, sine B cos A. So this is very useful, especially when we get to some part of integration or differentiation calculus. So there is to simplify trig, equation or trig functions. So how are they gotten? From the compound angles, recall. So from this two identity, we can get it for the first one, the sine A, sine B. This is sine A. Okay, sine A, sine B should be under cos, yes. But it's useful for this one, sine A cos B. This is sine A cos B, this is sine A cos B. So our aim is to make sine A cos B the subject. So what are we going to do? We add these two equations together. If these two equations are added, we are going to have this plus this. That's sine A cos B, which is this one, sine A plus B plus sine A minus B. This and this will cancel out. So I will let it what? 2 sine A cos B. If you add this one together, we'll be having 2 sine A cos B to be equals to this plus this. That's sine A plus B plus sine A minus B. And from here you can divide 2 by 2. So it means sine A cos B equals to half of, don't mind my handwriting, sine A plus B plus sine A minus B. So that's how to get sine A cos B. To get sine B cos A, if you want to get sine B cos A, you want this one to stand. So this time around we are going to add. We want this one to cancel away. So this time around we are going to subtract. If we subtract, this and this will go, we let it this. So we do this minus this. Minus give us plus. So this plus this give us what? This minus this. Then divide 2 by 2, you get this formula. So meaning this last two is gotten from what? Sine A plus B and sine A minus B. So product to sum formulas for sine A and cos B. For sine A and cos B is using compound angle for sine for plus and minus. Now, obviously, to get sine A sine B or cos A cos B, we are going to use what? The compound angle for cos A plus B and cos A minus B. Cos A plus B is cos A cos B minus sine A sine B. Why cos A minus B is what? Cos A cos B plus sine A sine B. So you want to know the value of what? Cos A cos B. This one. We are going to add this. Because if you add this, sine A sine B and this one will cancel out each other. So if you add this one, we are having cos A plus B plus cos A minus B. Because if you add this one, they are the same. So you have 2 cos A cos B. I can put 1 here. Nothing changes. So you can divide this by 2, this by 2, cancel 4. It means cos A cos B equals to what we have here. Half of cos A plus B plus cos A minus B, which is this. But if our aim is to get sine A sine B, this time around we subtract. If we subtract, this will cancel out. Then here we are having this minus this, that will be sine A sine B. This one here minus, what do we have here? Minus sine A sine B equals to this minus this. That's this minus this. So this and this will give us plus. So we are having 2 sine A sine B to be equals to this minus this. So to get sine A sine B, we divide by 2. That's what half will come here. So in short, you can do this yourself. Yes. To get this first 2, we either add these 2 or subtract. Over for this one, we add or subtract that of sine A plus B or sine A minus B. So please do this yourself and get this formula. So as we have product to sum formulas, we have the opposite. We also have the what? The sum to product formulas. And what are they? The sum to product formula for sine A plus sine B. Let's try for others too. Can you see the pattern? Plus minus minus plus. Is it not beautiful? Yeah, there's a pattern. The last one. So this is the one that spoil the pattern. For sine, we have sine cos. Sine cos. Cos. We expect to see cos, but yeah, sine cos. So just look in depth and look at the connections. Product to sum to product formula. Now the question is, how is this gotten? We understand how this come to be. So how about this one? Sine A plus B. You can always get this sum to product formulas from here. How? Okay, I want to get sine A plus sine B. So this way I have something close to sine A plus sine B. So by making this one the subject, so it means sine A plus B plus sine A minus B equals to, we can bring this to here. That will be 2 sine A cos B. What next? So we can let A plus B to another number. So let A plus B equals to, let's say, alpha. Let A minus B equals to beta. So in doing so, this one becomes sine alpha plus sine beta. This sine A plus B is alpha equals to then 2 sine, what is A? Now, what our A to be in terms of alpha and beta? So from here we have A plus B to be equals to alpha A minus B to be beta. From here, if you add, it means 2A equals alpha plus beta, then A equals to alpha plus beta over 2. So this A is what? Alpha plus beta over 2. Then cos B. To get B from here, instead of us to add, we subtract. A minus A cancel. B minus minus B, that was 2B equals to alpha minus beta. Then B equals to alpha minus beta over 2. Then it's come alpha minus beta over 2. So this is what? Product, sum to product, which is what? The first one you have here. Sin A plus sin B. Sin alpha plus sin beta equals to 2 sin A plus B over 2. We add this 2 over 2. We subtract over 2. We add over 2. We subtract over 2. So that's the product from, so that's sum to product. What about sin A minus B? Where do you have A minus B? So this is sin A minus B. So in this case, to get sin A minus sin B, we are coming here. We'll make this solver, we'll put this to here, and we'll use same approach. So from that, you can get the second one. I've done the first one, you can do the second one yourself. For the third one, we need sum of 2 cosine. So that's the sum. Same thing here. We'll bring this to here. Then we make alpha minus beta to be something, same approach. To get cos A minus cos B, same thing for cos minus cos. This is cos minus cos, the first one. Bring this to here. Then follow the same approach. So show all these 4 formulas yourself until you get the final answer. And this is the end of trigonometry. What is left here is just solve questions related to compound angles, double angles, triple angles, half angles, product to sum formulas, sum to product formulas. Those are the things we've done for this class. Thank you very much.